What if you could create a video game just by describing it? No code, no art assets, no engine. You type a magical forest with glowing mushrooms, and then you pick up a controller and start playing. This isn't science fiction. It's a new AI from Google DeepMind called Genie. And while it looks like a retro 2D platformer today, it represents a fundamental shift in how we might create and even understand reality itself. In early 2024, Google DeepMind unveiled something that looked, on the surface, like a charming but simple toy. They called it Genie, a generative interactive environment. The demos showed a series of basic 2D platformer worlds, seemingly generated from a single image. You see a child's drawing of a monster on a hill, and suddenly it's a playable level. You see a photo of a desert, and it becomes a world you can run and jump through. The internet's reaction was a mix of fascination and skepticism. It's cool, but the graphics are chunky, the physics are floaty. It looks like a game from 30 years ago. Many dismissed it as a clever tech demo, another curious experiment from an AI lad with a massive budget. After all, we already have text-to-image with DALL-E and Midjourney, and text-to-video with Sora. Is text-to-game just the next logical but ultimately niche step? It's easy to see Genie as a novelty, but that's the surface story. The truth of what's happening under the hood is far more profound. To understand why Genie is a big deal, you have to forget the idea that it's a game engine. It's not. Genie is a world model. It was trained on over 200,000 hours of video from publicly available 2D platformer games. Critically, these videos had no labels. The AI wasn't told, "This is a jump," or "This is the player." It just watched. By analyzing trillions of frames, Genie did something remarkable. It reverse-engineered the rules. It learned concepts like a character that is consistently controllable, gravity that makes things fall, and actions that cause predictable outcomes. It's a bit like how a baby learns about the world by watching, touching, and seeing the consequences, all without a formal physics lesson. The breakthrough is in how it handles player control. Genie has what's called a latent action model. It identified 8 distinct recurring patterns of change in the videos it watched. These are its latent actions. When you press a button on a controller, Genie doesn't know you mean jump. It just maps your input to one of those 8 latent actions it discovered and generates the next frame of video accordingly. You are, in effect, controlling the dream of a machine that has only ever dreamed of video games. So, Genie is not just making a video. It's generating a single frame, inferring a user's intent, and then generating the next logical frame in 1/10 of a second, creating the illusion of real-time interaction. This is a foundational difference from video models like Sora, which generate an entire non-interactive clip at once. Genie is a constant reactive loop between user and AI. And while the first version is trained on 2D games, the architecture is agnostic. Imagine training a future version on 1 million hours of Minecraft gameplay. It would learn the rules of a 3D block world, including crafting and physics. Train it on flight simulator videos, and it could generate a controllable cockpit. Train it on real-world robotics videos, and you begin to see where this is going. It's a scalable method for teaching an AI the cause and effect physics of any environment, real or simulated, just by watching. This is why researchers are so excited. It's not about making retro platformers. It's about creating a general-purpose model that can understand and simulate any interactive world. What does this mean for you? If you're an ambitious professional, especially in a creative or technical field, this points to a monumental shift. For game developers, Genie-like models won't replace Unreal Engine tomorrow, but they will become an incredible tool for rapid prototyping. Imagine an artist sketching a level on a tablet and instantly being able to playtest it. Or a writer describing a scene and having the AI generate a blockout of the environment to walk through. This dramatically lowers the barrier to entry for creating interactive experiences. Your creative vision becomes the primary skill, not your ability to code in C++. It could lead to an explosion of personalized, unique, and frankly weird games that would never be commercially viable under the old model. But the implications go far beyond gaming. These world models are a crucial stepping stone towards more capable AI agents and robotics. An AI that can learn the rules of a simulated world can then use that knowledge to plan and act in the real world. A robot trained in a Genie-generated factory simulation will be far safer and more effective before it ever touches a physical assembly line. This is how we build AI that can understand context and consequences, moving from simple pattern recognition to genuine world understanding. So, is Google's Genie the future of games or just a tech demo? The answer is both. The current version is a demonstration, a proof of concept. But the technology it's built on, a scalable world model that learns interaction from unlabeled video, is absolutely a window into the future. Not just for games, but for robotics, simulation, and our quest to build more generally intelligent AI. It's a reminder that often the most revolutionary technologies start out looking like toys. If you want to stay ahead of the curve on AI that will actually shape our future, make sure you subscribe to Decoded AI. We cut through the hype to give you the signal. Next week, we're decoding the world of autonomous AI agents. Can they actually run a business for you while you sleep? The answer is more complex than you think. See you then.